This is a video on the integration of trigonometric functions. And I've been following James Stewart's 6th edition calculus. You can also find it in his Essential Calculus Chapter 6. It's going to take me a few videos, I think at least 3, to get through this section. This is the first. And in this, I want to look at the situation where the power, you're integrating sine or cosine or mixture of sine and cosine, and at least one of them is odd to an odd power, and the other is to an even power or isn't there, which would be like to the 0th power. So we're integrating something in this form where one of these powers is odd and the other one is even. Okay, how are we going to do that? I'm glad you asked. So when the power of either sine or cosine is odd, but the other, if it's there, is even, well, first of all, we want to have this trig identity nearby. Remember this? Sine squared x plus cosine squared x equals 1. Remember that? That was just last year in trig we learned that, or in my case, more than 30 years ago. But that's not important right now. So we're going to keep this. This is one of the most basic trig identities, and we're going to hold it. We're going to keep this in our hip pocket for this kind of a situation. So, for example, let's say that we are asked to integrate cosine cubed x dx. Is cosine to an odd power? Yes, cosine is to an odd power, and we don't have sine around, so it works. Okay, so what we're going to do is, first of all, let's break out a cosine. It's a hot day, time to break out a cosine. So cosine cubed x equals cosine squared x times cosine of x. See, we've broken it out there. So now we've got a lone cosine. It's all by itself. So we're ready to go. And then what am I going to do with cosine squared x? Well, cosine squared x, if I subtract sine squared x from both sides, then cosine squared x equals 1 minus sine squared x, right? I'm going to substitute that right in there for cosine squared x, 1 minus sine squared x, and now we're ready. We are ready to rumble. So there it is. The integral. Now this is the same thing. We've just put it in a form that we can work with. The integration, the integral of 1 minus sine squared x times cosine x dx. All right, so we're going to use substitution in order to get this thing going. All right, I'm going to let u equal sine of x, right? So I'm going to substitute in u here for sine of x, and then so what's du? The derivative of the sine of x is the cosine of x. So du is cosine x dx. Now look what we have here. We're going to be able to put in the u for sine, and we'll have 1 minus u squared, and then cosine x dx, du, bam, look at that, look at that. Now we've got it in a form that we can handle, because we can do the integral of the first and we can do the integral of the second. Life is good. So let's do it. So the integral of 1 in this context is going to, we're going to get a u out of it, right? Because if we take the derivative of u, we get 1. So when we get integral of 1, we get u. Yay. And then minus the integral of u squared is going to be 1/3 u cubed. Why? Because when you take the derivative of this, 3 times 1/3, it cancels out, and we're left with u to the 3 minus 1, which is 2. Yep, everything works. And then plus a constant, because if there were a constant, the derivative of that would be 0. And so we have finally done it. We have found, by something that looked really hard, by using substitution, we've come up something that's very simple, because all we need to do now is substitute back in sine of x for u. So that becomes sine of x. This becomes sine cube of x, and there's peace in the world. So in general, if the power of sine or cosine is odd, but the other's even, if it's there, then we're going to save out one sine, or we're going to save out one cosine, so that we bring the odd power into an even power, and we have a lone sine or a lone cosine. Okay, then we're going to use the formula sine squared x plus cosine squared equals 1 to get it manageable. And then lastly, we're going to substitute u for the odd sine or cosine. That's not what we did, is it? We substituted it for the powered one. So substitute it for the thing that works. I'll put it that way. Okay, let me put it more precisely. Substitute u for the one that was odd, but that after you've factored it out is now even, okay? So it's going to be, if the cosine was odd, you're going to substitute it for the sine. Or if the sine was odd, you're going to substitute it for the cosine. It ends up being substituting for the opposite of what had been the odd power. But the thing that is now even after you've factored it out and everything. All right, so here we have our first video on the integration of trigonometric functions when you have either sine to an odd power or cosine to an odd power, but the other one, if it's there, is even.